You roped me into this, you better be at the front.
All right, we may as well get underway. Thanks so much for turning out in such big numbers. It's really heartening to see sort of events coming back in person and events starting to get really well attended. The first serverless meetup that we ran this year had a grand total of 6 people. So, it's really sort of starting to get back to normal, and it's really great to see everyone's faces, to begin to network again. There's a lot of work involved in running serverless meetups and the like, and so Nelly has been a long-time member of the serverless community here in Sydney, presented at Serverless Days Sydney, Serverless Days before COVID and things like that. So she'll be just helping out, with organising the meetup and stuff like that. So, if you find me too sort of intimidating, too scary, then you've got a very nice person to deal with instead. She's in fact roped one of her colleagues along, Angus, Yuen, to present tonight, software engineer at Atlassian. He will be talking about a project that he did for a sort of Cantonese translator extension.
Yep.
Chrome extension, is it?
Chrome and Firefox.
Oh, okay, yeah. And he went all in on serverless for that one. So that's going to be a really cool talk. But yeah, round of applause for Nelly. Thanks so much for offering to help out. Really appreciate it. So thank you. You can tell I'm a little bit rusty on the whole hosting thing, but we'll get there. Our second talk for tonight is Nehzat, software engineer at thanks.dev. He's going to be doing a lightning talk on making open source sustainable. That's going to be a really, really cool talk. I had a quick little look at his product, and I think open source is a really big part of the sort of what we do as serverless engineers. So I think that's going to be awesome to find out about that. And then lastly, we've got Hilton Rosenfold, pre-sales architect at DataStax. He's going to take us through a Netflix clone using AstraDB and GraphQL. AstraDB is DataStax's serverless Cassandra offering. So that'll be really cool as well. So 3 awesome talks. But first up, we have Angus, and I think that's going to be really cool. So take it away, Angus. Cool. Oh, and one last thing. Remember, questions, you get to win one of these. Awesome.
Good evening, everyone. It's good to see you all tonight. My name's Angus, and I'm a software engineer at Atlassian. I'm going to start off this talk a little different by starting back to where I was born, because this was actually the motivation behind my personal project. So I was born in Hong Kong, and at the age of 3, I moved to New Zealand. And just like many young Asian immigrants to Australia, English quickly became my native language, while Cantonese took a backseat as my mother tongue. When I hit 18, I decided to move to Sydney to pursue a degree in software engineering. I joined Atlassian at the beginning of the year, and before Atlassian, I was a software engineer at Amazon Web Services. This is a photo of the Amazon Sydney reception, which I finally got a clean photo of with no one around because this was right between COVID lockdowns. At AWS, I worked on the AWS Managed Services product offering. This is where I built services for enterprise customers to help augment and optimize their operational capabilities in both new and existing AWS environments. I was part of the monitoring and logging team, where I worked on the infrastructure and algorithmic design of projects around best practice tag management, monitoring, alarm management, and log management. A lot of what I worked on is currently in the public AWS Managed Services documentation linked here. And as an engineer, as you all know, it's always nice to see your things out there in public and being used every single day. At AWS, this was where I really got into learning how to use cloud services like Google App Engine, and Google Functions. So I got to use these services to build and host large-scale services capable of handling hundreds of thousands of requests per minute. Wait a minute. Hey, just kidding. Amazon uses their own cloud and not Google, obviously. So this is where I actually got to work with serverless products such as AWS Lambda, step functions, API gateway, you name it, everything on this list here. And at times, I'd count myself lucky enough to even be able to get to speak to engineers from AWS Lambda team or even read documentation from the AWS config team to really understand how these services worked under the hood. Now, this talk isn't about my experience at AWS. It's titled, Why I Went All In on Serverless for My Personal Project. Now, I mentioned I was born in Hong Kong, and I moved to New Zealand at a really young age. Cantonese is the primary language spoken in Hong Kong by over 60 million people across the world. However, it's known to be quite a difficult language to learn due to its tonal system and a severe lack of resources on the internet, especially outside of the city. So even though Cantonese is my first language, and when I speak, people think I sound like a native speaker, in fact, my vocabulary is probably equivalent to a 6-year-old. Give me a news article, and I can probably only read about 50% of the Chinese characters. Not only this, the number of people speaking Cantonese has been on the decline for the last 30 years. So I wanted to make an effort to preserve my own mother tongue. From the graph, you can see that the percentage of speakers of Cantonese within Hong Kong has slightly declined between 1996 and 2016, while the percentage of speakers of Mandarin have almost doubled, growing at a faster rate than that of English. It was with these reasons that motivated me to build a web browser extension called Canto Translate, which translates highlighted traditional Chinese text to English. The idea is that while I'm reading an article, if I come across a word I don't know, I'll be able to immediately look it up, look up the list of English definitions, as well as just listen and hear how it sounds so I don't have to worry about the tonal system at all. In other words, what I wanted was a pop-up dictionary in the browser for Cantonese with text-to-speech capabilities. So at the time I built this, I did some market research, and I found 2 or 3 very similar extensions, but they didn't provide text-to-speech capabilities. This was something which was asked around in like Reddit forums. They were also unmaintained for over 7 years, and the GUI was just plain outdated. So decisions. So the first thing that I needed to think of in working towards this app was I needed 2 particular APIs. I needed a dictionary API so that for a given highlighted word, I could get back a list of definitions. And the second thing I needed was a text-to-speech API. The text-to-speech API was fairly simple. I found an online API called WebSpeech, and this was free to use, and it was very easy to integrate with, so I decided to use it. For the dictionary API, this was very surprising to me, but the Google Dictionary API was deprecated back in 2011, and Bing also doesn't provide a dictionary API. They sort of don't have that anymore, and they just have one translate API. So I did some thinking, and I realized, hey, there are a finite number of words in the dictionary, right? There's only around 120,000 words in the Cantonese dictionary. What if I just ingested those 120,000 words into my own database and built an API on top of it so that developers all around the world can also use this, and they won't run into the same problems that I have? So I wrote a Python script to ingest those 120,000 entries into my own database, and I built my own API. This is also going to be a pretty simple API to use, to create and use, just a single endpoint. From the user perspective, what they would want is, given a word, we would be given back the pronunciation of the word, like the romanization spellings in what you would call pinyin and zhutping. These are basically ways for English speakers to understand how to pronounce these Chinese words without needing to understand the characters. And obviously also a list of definitions for the input text as well in English. So pretty straightforward API. And at this point, I had to start thinking about the infrastructure. So I had 3 avenues. So choice 1 was to host the database and the server on an EC2 instance. My second choice was to host the server on EC2 and the database on maybe a data store like DynamoDB. And what about the third choice? Perhaps I could host a server on Lambdas and host the data store on DynamoDB. Given this is a serverless talk, it's no surprise that I probably went with choice 3. But let us dive into why I didn't go into choice 1 or 2 at the time. So I'm going to go through my decision-making process here. So choice 1, host server and database on EC2. There are a couple reasons why I didn't host the server and database on EC2. So with the cloud, there's a lot of maintenance overhead that comes with EC2 instances. Just because cloud is an abstraction over your servers, it doesn't mean that it's completely hands-off. For one, with renting EC2 instances, you still have to manage your own security groups, you still have to manage your firewalls, and make sure that we only allow intended traffic and block out any malicious actors. In this example here, if you can see, we've got a security group which basically just allows traffic on ports 22, 80, and 443. So this would essentially block out any traffic against any other ports. Let's say if we had an application on port 3000, this security group would basically not allow that connection to happen. Also, what we want to do is probably host the database on a separate EC2 instance instead of the same EC2 instance as the server, so that we can scale the server and the database independently due to different scaling requirements. Also, by moving the database into its own EC2 instance, we now further isolate the database from a security perspective and reduce blast radius should one of these components be compromised. And not only that, we also have to think about networking. How do we set up our VPCs? How do we set up our public and private subnets? And also, if you want to set up a public subnet, you also need to set up an internet gateway. And that internet gateway is used to allow us to initiate connections between users outside of the cloud and with resources within the VPC. And not only that, we probably also want to put our database into a private subnet as a best practice to ensure that we don't allow any external users directly accessing it. Because instances in the private subnet don't have a public IP address, just a private one. We also have to perform regular patching and update of our instances whenever a new Amazon machine image is released. And this naturally comes with downtime of our service, where I'd have to start specifying maintenance windows and communicating this with my users so they know that my app is down during specific times. And let's say if I didn't want any downtime, I'd have to start getting my hands dirty with elastic IP addresses and building my own monitoring script to make sure that it gracefully fails over and also reattaches the elastic IP should that instance go down. And if I didn't want to start messing with elastic IP addresses, I'd have to start considering creating a load balancer and setting up auto-scaling groups and also configuring a health check at the load balancer to make sure that the load balancer only routes traffic to an available instance. And while all this is happening, don't forget that I have to pay for all the uptime of these AWS services, whether I'm getting requests from the customer or not. Yeah, okay, this is heaps of stuff to do. What did I want to do at the beginning? I just wanted to learn Cantonese. And I don't think managing health checks or instance upgrades is going to help with any of that. So for choice 2, this led me to think, what if we decided to, instead of hosting our own database, move this into DynamoDB? And this is very similar to choice 1 in the fact that we still have to manage our own server, but DynamoDB is now completely managed by AWS. So for this solution, security would basically just be handled by IAM policies. I wouldn't have to worry about putting my DynamoDB in a VPC. I wouldn't have to worry about putting it in a private subnet. And not only this, AWS also handles replication of our data across multiple nodes so that if a single availability zone goes down, our data is not lost. So there's some resiliency there. And it's also important to note that DynamoDB allows us to configure it as a provision capacity mode or on-demand capacity mode, where provision capacity mode is where we set a provisioned amount of write capacity units and read capacity units. And it's great for use cases where we know our traffic. And if we get spikes of traffic, and if those spikes of traffic go beyond the amount we've allocated, then those requests start getting throttled. So instead of using provision capacity mode, what we have is on-demand capacity mode, which although is 7 times more expensive than provision capacity mode, it's really good for services where we have unpredictable traffic and we only get billed per request. So this seemed like a really good use case for my app because I don't know how many people are using it, quite frankly. So build per request. These couple of words got me thinking. I mean, I'm sure I'm not going to get many hits for my browser extension, maybe about 200 requests a month. In fact, I'm not even expecting to get any requests for hours or even days. So it would be really nice if I didn't have to pay for that 24/7 uptime of an EC2 instance, which I did the math. For a T2 Micro, this is about $8.50 a month. But what if I decided to put that $8.50 a month into an index fund which tracks the S&P 500, and assuming an annual return of about 7.5%, and with compounding, after 40 years, wouldn't that grow to around $25,000? Okay, disclaimer, that was a joke. I am not a financial advisor. Please do not take that as financial advice. So this naturally led me thinking, perhaps we could go and leverage full serverless. What if I decided to, instead of having EC2 instances, I decided to host my backend on Lambdas and have those Lambdas query DynamoDB. With DynamoDB on-demand capacity and AWS Lambdas build per request, I would effectively only have to pay whenever someone makes a request. And remember that Amazon provides an always free tier. So for Lambdas, this is around 1 million requests per month. And since my traffic expectations were what, maybe around 200 requests a month, 200 is less than 1 million. So what, Lambdas are basically free for me to use, right? And let's say even if my traffic expectations were wildly incorrect and I get way more than 200 requests a month, remember that this serverless architecture is completely elastic. For every single request I get, Lambda will be able to spin up a new container. And it can also ensure that we're able to handle any spikes in load. Note that there are limits to how many Lambdas you can run in your AWS account. This is about 1,000 concurrent executions. But it does burst to around 3,000 concurrent executions as far as I know. But this is a soft limit. And if you want an increase, you can just raise a support ticket with AWS and they'll increase it for you. So I have Lambdas and a DynamoDB. At the time which I built this extension, you guys might remember that there was a release which happened, well, sort of half release, where AWS released a blog about Lambda URLs. Lambda URLs is basically like a very new feature where Lambda exposes a URL for you to directly invoke from the client. So at this point, Lambda URLs was not actually an available feature, so I couldn't use Lambda URLs. So because this wasn't available yet, I had to think of different options. So I had two options here. Either front my Lambda with an API gateway or front my Lambda with an application load balancer. So two choices here. I ended up deciding to front my Lambdas with an API gateway because API gateway has account level and API level throttling to protect my Lambdas downstream should I receive a spike of requests. This was the first time I hosted my own public personal service, and this was something I was actually pretty concerned about. Like, what happens if they kept DDoSing my service and all the Lambdas went out of control and my costs rocketed, right? I can't really afford $2,000 a month or something like that. So I ended up just deciding to bite the bullet. I felt like API gateway built-in throttling was probably good to go for now. And if things really did go bad, I could just deploy AWS Web Application Firewall right in front of it so that I can block out certain IP address ranges or geographies if I needed to. Not only this, API Gateway can also perform request validation to ensure that it doesn't pass on any bad requests from the clients, further protecting my Lambdas from scaling out to serve those bad requests. And if any other developers wanted to use my API, don't forget that API Gateway allows you to automatically generate clients in Swift, Java, JavaScript. So yeah, that was a really handy feature as well. And API Gateway and AWS Lambda also come with a bunch of free Cloudwatch metrics as well, so that I can create my own operational dashboard to understand the health of my service, such as call volume, end-to-end latency, and faults. And just a quick recap of the choices I had against the 6 pillars of AWS well-architected framework. I'm just going to be focusing on the 2 extremes here, just choice 1 and choice 3, because choice 2 is sort of an in-between, and I don't want this talk to go on for too long. So in terms of security for EC2, remember that we had to configure our own security groups and VPCs and subnets to manage who can actually access our services. While all of this is handled by IAM policies and serverless. And in terms of performance, I didn't mention this earlier, but for EC2, it's on demand and it's ready to process requests at any single time. Whereas with AWS Lambdas, those of you guys who really love AWS Lambda will probably know that there's something called AWS Lambda cold starts. This is the time it takes for basically the Lambda service to allocate your Lambda container to an appropriate EC2 fleet to run on. And this process takes around 100 milliseconds to the P100 worst case scenario of 5 seconds. So Lambda cold starts will add a bit of latency. But in terms of operational excellence, for EC2, we'd have to manage any database updates or AMI updates and security patches and handle all of that downtime. While with serverless offerings, it's all managed by AWS. In terms of cost with EC2, I'd be billed for 24/7 uptime, while with a completely serverless architecture, I'd only be billed per request. And for reliability, to handle failovers gracefully, for EC2, I'd have to set up load balancers and auto-scaling groups and all that kind of jazz. While with serverless, we really leverage the elasticity and the ability to scale up on demand with serverless offerings. So the final architecture turned out pretty simple. All the serverless components are deployed in the AWS Managed VPC on the right in my AWS account, so that they automatically have internet access because they're in the AWS Managed VPC. Users install the Chrome or Firefox extension on their browser, and then basically they just search for a word, it fires off an API request, API gateway then forwards it to the appropriate Lambda and fetches the results back from DynamoDB. Super simple architecture, anyone can understand it. So deployment. Let's talk a little bit about the deployment piece. How do I deploy this? So I deployed API Gateway and Lambda via CloudFormation. But unfortunately, at the time, I decided to manually manage the DynamoDB. I guess I just wanted to get this shipped as quick as possible. But I do have plans to import the DynamoDB back into the stack using the CloudFormation importing feature. So when building serverless infrastructure, I leveraged AWS SAM, which is AWS Serverless Application Model. It's basically an open source framework for allowing you to build serverless applications with ease. Effectively, it provides a bunch of shorthands on top of vanilla CloudFormation to reduce the amount of boilerplate required to build common serverless patterns. And you can enable this in CloudFormation by simply just specifying a transform at the top of the file of your CloudFormation template. So let me give you guys a concrete example. What does this actually look like? So let's say we wanted to build a function which gets hit by an API gateway whenever someone queries a /hello endpoint. This is what it would look like with AWS SAM on the left. You get these special serverless resources with AWS SAM, and it's that red arrow right there. Serverless function, this is about 13 lines of code. But if you wanted to do this in native vanilla CloudFormation, this would probably be around 50 lines of code where it'd have to set up many different resources like the Lambda permission resource, the API gateway, stage and deployment resources, and just a bunch of resources. So if you guys are ever building out serverless applications on CloudFormation, I highly recommend AWS SAM. And let me just update my architecture diagram with the deployment flow. So now we have an engineer at the top who writes the CloudFormation templates in SAM and basically just deploys it via CloudFormation to our AWS account. Let me give a super quick demo of my extension of Canto Translate. So I found a, sorry guys, but this extension isn't actually supported in Safari, so I'm just going to have to bring up Chrome. Okay. Oh no. Okay. 1 moment. Let me quit out. Oh. Could be the other way. Let me try. Uh-oh. Technical difficulties. That's not good. Uh-oh. What can I do? I'm not sure. Oh, it's not showing up, is it? Oh, that's a bit unfortunate. I'm happy to skip this demo for now, but I do have another demo which I'd like to give you guys. Oops. Oh, this is terrible. Okay, there we go. Okay, and as for the Cloudwatch dashboards, I mentioned that we get free API gateway and Lambda metrics to go with it. So here's the operational dashboard. Thankfully, it does work in Safari. Okay, so operational dashboards are another like pet topic of mine. Like I'm really motivated about this kind of stuff. So on the top left, you can see that I've got a core volume graph. So as I sort of expected, I get like a couple hours where I'm not getting any traffic at all. But what I was surprised about was that I get around 311 requests per week, which is way more than what I expected of 200 requests a month. And as you can see, the end-to-end latency is around 2 seconds. It's around 2 seconds. This sort of makes sense because my infrastructure is actually only deployed in Sydney and AP Southeast 2, because I sort of just wanted to optimize this experience for myself. But when I started looking at the Chrome dashboard and saw the metrics, I saw that I'm actually getting users from like America, from Hong Kong, and even like places like Chile and Pakistan, which I didn't really expect, which is super awesome. And don't forget that we get Lambda cold starts as well, so it does take some time for those Lambdas to start up. I'm guessing that these dips down here, down to like 39 milliseconds, is probably requests that I made myself in succession, so these were probably warm starts, Lambda warm starts. As for request processing failures, we didn't get any recently, but if we try to extend this back to like 6 months, you can see that we got a couple spikes here. The first 3 are mostly due to my own testing, but you see one small spike down here around like April 2nd. That one was due to an AWS intermittent failure, but I didn't really have to worry about it. I didn't have to page myself or wake myself up because what the user just has to do is just like retry highlighting another piece of text again, right? And it would immediately work for them. As for the cost, you can see that I'm mostly at 0. There's a little like step up here, up to like 18 cents. And the reason why it's 18 cents is because I only have one AWS account. I've lately been experimenting with AWS RDS Aurora Serverless, and I only kept that up for like a couple hours, and apparently it charged me 18 cents. But you can effectively see that I've hosted this application with around 300 requests per week at effectively $0 per month. Cool. Okay. In summary, remember, all I wanted to do was to learn and read Cantonese literature. And what I did was I created this application called Canto Translate. And as part of the decision-making process, I decided to build my own API. And I had to think about how to host the API on traditional EC2 versus serverless. And what I ended up finding was that serverless had way less operational overhead, had way less cost, and could basically absorb all the spikes of traffic I'm getting. And that brings me to the end of my talk. If you'd like to learn more about AWS and Python, I write a lot on my Medium. And if you also just want to plain old connect, feel free to add me on LinkedIn. This was the first ever talk I've given, so I hope that you guys brought something away with you guys today, like at least if there's one thing that you guys learned. And I hope that I've sort of convinced you guys that instead of managing our own servers, let's just go with serverless for your next personal project.
Awesome. Round of applause. Thank you. All right. Any questions? If it's a good one, no pressure. You got one? Yeah.
Probably not a good one, but we'll give it a go.
Yeah.
Have you thought about extending this to other languages? Because isn't it just more data? Like once you want anything else, any other language, you just put more data in your database and
so most of my motivation was behind the fact that I wanted to personally learn. So this was more like a personal motivation rather than like trying to cover as many languages as possible. But I did create an application just like this many years ago for Japanese as well. But yeah, that's definitely like an avenue I could look at.
Have you done any data analytics to see what the most common words are? For example, swear words, I'm guessing.
No, not yet. I don't really, to be honest, I don't really know what kind of data I can and cannot collect without like infringing on people's privacy. So at the moment, I'm just using, there's basically very little logging at all. And most of my metrics are just the default Cloudwatch metrics, the default Lambda and API gateway metrics.
So just to repeat for the live stream, that question was around, have you done any data analytics? Yeah. Next question.
I was going to say, did it work? Are you now fluent in reading?
No, but it has actually helped me reading in like forums and stuff. It's pretty neat because like, I don't know if you guys feel the same way, but it's sort of like a video game, right? Like you sort of unlock a new area to explore. Whereas with this sort of analogy, it's like, oh, I'm learning a new language and I've explored a new area of the internet. Like, yeah.
While you were building, did you have any unexpected challenges or surprises?
Unexpected challenges. Yes. So I think that's a very good question, actually. Jumping straight to DynamoDB probably wasn't the best. Jumping straight to DynamoDB as a data store probably wasn't a wise choice. Reason being is because, as you know, DynamoDB's basically it's most efficient when you query for a particular partition key. There's no sort of search for like anything. So let's say if a user searches a substring of like a word which is actually valid, but that substring is not valid, you can't actually search for that word. But what I would have liked is to search that substring and search for any other words which contain that substring, basically. And I think, from what I know, as far as I know, I think relational databases do actually allow you to do like pattern searches. So yeah, that's one thing.
Hence Aurora Serverless. Postgres.
Yes, that's why I was playing around with Aurora Serverless.
Nice. Up the back, last question maybe. Yeah.
Did you try to optimize it for some searches on Google so people can find it easy?
So
Or did you figure out how people actually find me on Google?
So this one, I haven't looked too deep into it, but what I did find is that apparently on the Google Chrome store, they sort of optimize you for if you do, the more releases you do, and also like the title of your application and the description. So yeah.
Well, round of applause for Angus. Once we finish tonight, we'll sort of, do a bit more networking. And, obviously, Angus had his QR codes up, so you know where to reach him.
Yeah.
Thanks once again.
And if you guys want to see the demo, I'm happy to give it.
All right. I'll be giving out a couple of the books, so well done. I'll get a few more of you while Ali sets up.
Oh.
I will give you this as well if you want. Ali, do you want to clip on?
Question? Oh, thank you.
Yeah.
Oh.
So have a clip on the top of your shirt, and that can just go into your pocket. Oh, yeah, I'll grab that. Just turn it off.
Is this okay?
Thanks so much.
Thank you.
Yeah, sweet. Awesome. Nearly done? You nearly ready, sir?
I'm ready. Let's rock and roll.
Awesome. Well, we've got Ali and Nehzat for a quick lightning talk. So, if you're ever interested in doing a talk at the Serverless Meetup and perhaps, you don't have like a full talk ready, you can always do a lightning talk. I'm sure Ali could have talked to us for hours about this, but we're very grateful to have a lightning talk about thanks.dev. Take it away, Ali.
Thank you.
Did you share your slides with
I didn't get that memo.
How
do I do it?
That memo. 1 second, folks. Do you want to check your email? Maybe unplug real quick. No, right now, because the live stream, we're just gonna go
So
through it.
in the calendar meetup?
Yeah,
Or...
in your email. Did I send you a message?
No.
Refresh.
Is it a quick install?
Huh? So can you go to this link? Prepare myself. Take it away, Ali.
Awesome. Hi, everyone. Hi, everyone. My name is Ali. I'm here to talk to you about thanks.dev. The mission is making open source sustainable. It's an app or a project that is just about to launch. Before I get started, though, I'd just like to thank Peter for inviting me, giving me this opportunity to talk to you all. Thank you all for coming. It's so nice to see people. It's so nice to see people face to face again, not behind monitors and screens. So it's good to be back out of COVID. In case you can't read this, this is a very famous XKCD cartoon. It's very popular in the open source community, and it just reads, a project some random person in Nebraska has been thanklessly maintaining since 2003. All the tech stacks that we work on look like this, but I thought I'd give you actually a really concrete example of this. I'm going to talk about Node Postgres. It's a package we use in Node.js. I'm sure a lot of you are familiar with it to connect to a Postgres database. But there's a couple of tidbits of detail that I want to share with you. Number one is that it gets about 3.1 million downloads per week. And if you go down, it's maintained by one person. And this is going to be a fun story. So his name is Brian. He doesn't work out of a basement in Nebraska. I think he actually works in Texas. And if you go into his sponsors page, he's only got 28 sponsors. The majority of these sponsors are other open source developers. This Benji guy I've talked to, Raphael I've spoken to, and about 70% of his sponsors are probably in the $1 or $5 a month category. And they're all developers. There's very little sponsorship that he gets from the community. But what gets even worse is that Brian, if I go onto his Twitter account, one of his last tweets is in July 2020, and it reads, woke up today to some extremely offensive words from a frustrated user on GitHub. Pretty much trashed my day. Remember, your open source maintainers do this work out of love. Please be kind. We don't write bugs on purpose to trash your day. Don't wreck ours. So it's a pretty big problem. And basically, if I were to summarize it, the problem is that maintainers, they're creating so much value for the economy, for the ecosystem, and they're not getting treated fairly, and they don't have much independence. So they're pretty much working a 9-to-5 job, and they're doing this out of love in their spare time, and they're pretty much getting abused. There's a lot of talk of burnout, and there's a lot of problems within the mental health space for these maintainers just because they're so overworked. And what they actually really want is fairness and independence, and they want to get remunerated fairly for the amount of value that their code is creating. But the problem is it's really hard for companies to donate to them. They all get stuck in the bureaucracy of procurement inside companies. And more importantly, they don't know who's actually using their software. Like Brian has 3.1 million downloads a week, but he doesn't know who's downloading his software. And this is where thanks.dev comes in. So basically, on the company side, thanks.dev makes it really easy to support the open source projects that your company depends on. Basically, a company comes online, they specify their monthly allowance, monthly donation amount, anywhere from $10 a month to $100,000 a month. We analyze their code base and trickle down their donation down their dependency tree. For the maintainer, basically the funding equation becomes absolutely seamless. They get funded by the companies that use their software, and maintainers can focus on writing code and not have to chase sponsorships and donations. Now, for a little demo, this is the thanks.dev account once you log in with your GitHub account. What I want you to pay attention to is the 675 dependencies that thanks.dev itself depends on. And the core of the system is really simple. Basically, the dependency tree has been broken down to these percentages. And the way it's calculated these percentages is it has gone through all the repositories in the thanks.dev account itself. and it's created a list of dependencies. So Brian is quite up there because it's a very database-heavy application. And when it comes time to donations, the $1,000 a month got charged on the 25th of April, and Brian would receive $122 of it. And we don't care about that one. So a quick recap. It's a big problem. Thanks.dev is a very simple solution to this problem. If you're interested in this space, please come and talk to me. If you know someone who's interested in this place, please come and talk to me. And if you work for a company that uses lots of open source, which I'm assuming everyone here is, please come and talk to me. And I look forward to talking to you all and meeting you all. Thank you very much.
Round of applause.
Thank you.
Does anyone have any questions for Ali over there?
Yeah, can you explain a bit more about how this is calculated, like the lines of code? Or
No, it's not lines of code. So basically, what I do is I go through the entire organization, all the repositories in the organization, find all the open source dependencies, create a massive data structure of the tree, and then collate and score each one of the dependencies according to the tree. So it's basically it's half at each level. So basically the scoring algorithm halves at each level of the dependency. So the higher you are in the dependency tree, the more of the donations you'll receive. Yeah.
So the question was around how is the sort of, I guess, distribution calculated to the open source providers based on, I guess, the packages that you use or the dependencies. Rich Buggy, did you have a question?
How do you deal with like dev tools that are usually installed globally rather than part of the package? Because quite a lot of the time, it's like the first instruction for the developer is npm install this globally, so it's not actually going to be in the GitHub repository.
Or Linux, or I depend on Postgres, Redis, which doesn't come in. Do you
So
want to repeat
the question was around sort of npm packages that you install globally that might not be listed as one of your packages in your, say, your package.json. How do you handle that particular edge case?
Yeah. So what sorry, let me get my words straight. There is a global list that you can allocate as well. Yes.
Well, get the, sorry.
How's uptake of thanks.dev in private companies?
Sorry, how do you mean?
So if like a private organization whose code is obviously proprietary and worth a lot to them, but has anyone started using thanks.dev for that?
Yes. So a few of the early, do you want to repeat?
Yeah, I was just going to repeat the question just for the live stream. So I guess the question was around uptake for private companies, but also how do private companies navigate the sort of use case where they perhaps don't want someone scanning their code. How do they share their dependency tree or something like that externally?
Thank you. So there's a couple of ways of dealing with it. A few of the companies, the early adopter companies that I'm dealing with are financial institutions and really sensitive. They have this problem. So I provide an API that they can upload the dependency list themselves. Or alternatively, if they don't want to write code and maintain those things, there's also a Docker container that they could run within their own network that only downloads the manifest files and uploads it via the same API.
Okay, yeah. So,
Have you considered using this to tell organizations about vulnerabilities found in those packages?
So that's actually considering security aspect of vulnerabilities. The question is around security aspect of vulnerabilities. It's a very active space right now. There's a lot of companies that are already doing that. The focus on our side right now is not so much the security aspect of it, it's more the sustainability aspect of it. There's already a lot of companies active in this space. Snyk is one, they're very well funded. So I don't think we could add a lot more value there right now.
How do you work out with multi-contributors doing work on the same piece of code, or if another developer has used this code, they've made their own open source, and then you've gone from there, so you've technically sort of got a stream of coders?
Yeah, so that's actually a couple of questions packed into one. The first question is, how do you deal with a project that has multiple contributors? And the second question is, how do you deal with forks of projects? With the contributors, basically the project will have a thanks.json file that they agree on themselves inside the project that will then tell thanks.dev that any donation that comes in for ESLint, for example, split it according to these percentages. With respect to forks, that's a little bit undecided right now, and there's a lot of corner cases like this that come up. For example, I depend on you, you depend on me, what happens in here? That one I've actually dealt with, but the fork is very difficult to deal with, and I think it needs a bit more feedback. So that one has been paused. Yeah.
Awesome. I reckon, yeah, just one last one, and then it's been a really good bunch of questions that we've had. Go for it.
Yeah, I think it's a fantastic idea. It's fantastic.
Thank you.
Just one, I'm thinking from an eagle perspective. Could package maintainers roll the system a bit by splitting their package up into 10 different packages that all depend on each other?
No.
Okay.
No.
So you're
Yes. So the question was, can the system be routed? Yes, there's always a possibility of things getting messed up, but not that way. No, that one and a lot of the other ones have been taken care of. Yeah. So you can't depend on yourself. If I work for a company that depends on one of my packages, they can't donate to me. All of those things have been taken care of. Yeah. Awesome. Thank you so much.
Thanks Ali.
everyone.
Appreciate it. Up next, we've got Hilton from DataStax. Vinci, I reckon your question was really good, so congrats. All right. Managed to get your screen sharing and all that sorted out. Sweet. I'll get you to clip on at some point as well. Yeah, just clip it on somewhere. It's a bit awkward, isn't it?
A little bit. Okay.
Clip that onto your pocket.
Sure. Thank you.
All right.
It's very pink.
It's very pink. Let's try again. Wasn't pink when I tested it before.
Serverless Meetups hyper commercial, so you get a really awesome peak cup.
There we go. Thank you.
Because pink was a bit much.
These actually, I've got one at home, and they like keep your coffee warm for like 3 hours. It's the only way I've been able to survive in lockdown for so long.
Yeah, they are fantastic. They're 3 separate layers of aluminium air-gapped for thermal isolation. Yeah, wow.
DataStax, don't worry about that. It's really the keep cup. No, but
Well, that's the reason we joined the company, to get the cup.
Exactly.
Yeah.
All right. Take it away. Thanks, Hilton.
All right, thank you. Well, good evening, everyone. Really good to see everyone here today. I'm very happy to be here to talk to everyone. My name's Hilton Rosenfold. I'm a pre-sales architect, or as we call them at DataStax, a data architect. And I've been working at DataStax just recently, just started working there 2 months ago. DataStax is a very fast-growing company, especially in this part of the world. For those that don't know DataStax, the company's been around for 12 years, and we work with Apache Cassandra, which is a NoSQL database. The company started helping organizations manage their on-premise implementation of Cassandra, and these days we now run a serverless version of Cassandra where you just write data and read data and don't have to worry about anything else. So today what I wanted to do is just show you a little bit about how easy it is to work with DataStax in our product called AstraDB. AstraDB is the serverless version. And I'm going to show you a little demonstration of creating a Netflix clone. So our own little personal Netflix server with lists of movies and how that would work in the database. We're going to do the front end in React, and we're going to use Graph Query Language as the API. So structure of the application, just like I said, Astra database underneath, GraphQL to connect to the database from React. And React, for those that don't know about React, it's really good for interactive websites where user input on the screen redraws the screen for you and running some code in the back end there. I'm not going to get into React. I'm not going to get too deep into GraphQL either. The focus for me today is to talk to you about Astra, but I will show you a little bit in the React code just how easy it is with the APIs to connect. So a little bit about Astra. What is Astra? I said before, it's Cassandra database as a service hosted by DataStax. It's serverless, which for this group here is quite appropriate. Databases are fun, but they're not fun to manage. So we look after that for you. And essentially, we achieve the ability to run any level of workload. Some of the world's biggest organizations run on top of Astra, and they run for zero downtime. We've got customers that have achieved 100% uptime for greater than 6 years. Not a single outage for greater than 6 years. We operate at global scale and zero lock-in. You can run your workload in any cloud provider, in any area, in any region, in any data center, and on-prem as well. You only pay for the resources you use. So you pay for reads and writes, a little bit for data storage, and that's it. No infrastructure to pay for, no storage to pay for, or storage resources anyway. And definitely no need to pay for DBAs or server admins or network admins. Just developers. That's really where we focus, is making the database easy to use for developers so that they can focus on writing code to satisfy a business need. We have a free version available, so you can just go to our website and sign up for Astra. When you sign up, you get $25 of credit per month, and that just renews every month for as long as you want. What does $25 credit give you? It gives you 20 million reads and writes per month, which I think is a fair amount of reads and writes. Although these days, with the way data is growing in the world, 20 million reads and writes can be consumed quite quickly, and 80 gigabytes of data storage. DataStax over the last 12 years has been, and is still today, the largest contributor to the Apache Cassandra project, the open source project. We actively contribute everything that we develop in our enterprise version to the open source community. Generally, there's a lag of about a year between what we are hosting in Astra Serverless to what the open source community version of Cassandra offers. And that's just the normal Cassandra submission process. Can take a little bit of time to check things, approve things, and that 1 year lag is there. Astra actually also includes a couple of other things that I'll quickly mention. It also includes an event streaming engine. So what I mean by event streaming is any change that happens to the data in the database can be streamed out to other services. What this really enables is the ability to start working in real time. For example, data at rest in the database, that's valuable. But generally what we have to do is, if I want to query the data, I need to, or if I want to analyze the data, I need to do a batch job, process it, and schedule a report, something like that. What's far more powerful is in real time, as the data comes into the database, as writes come into the database, is to process, do some processing, whether it's filtering that data, augmenting that data, add in or merging different data sources together, whatever it is, process that data and take immediate action on the data as it's written into the database. That is event streaming, and Astra includes that. In your $25 of free credits, you get Astra event streaming as well. Okay, I'm going to do a little demonstration, and then I'm going to come back to the slides just to show you, while the demo is running, what's happening under the hood. Just actually, is anyone in the room familiar with Cassandra as a flavor of NoSQL? Yep. Anyone else? Yeah, we've got a few. Okay. Anyone not familiar with NoSQL at all? Any flavor of NoSQL? As in zero experience with NoSQL? Anyone? Or, okay. Familiar, right. So maybe what I should do is also just say what Cassandra offers. Cassandra is a distributed NoSQL database. I'll come back to that with a slide, but I want to kick the demo off just so it can do its little bit of work in the background. Okay. So to start the demo, we very, very simply go to the Astra portal. This is what I see when I log into my Astra portal. It's a dashboard. It tells me I'm on a free plan. It tells me I've got $25 of credit. And it tells me that I've got one database currently provisioned and how many reads, writes, and storage that database has used already. What I want to show you is creating a new database for our Netflix project. And then we're going to use some of the developer tools to add a schema to that database and to load some data into the database. So to create our serverless database in Astra, I click on Create Serverless Database, and I've got to give it three pieces of information. A database name, and I'm just going to choose Workshop. A key space name. Okay, what's the difference between a database and a key space? Think about a key space as the schema itself that will hold the actual tables, if I am using tables. The second piece of information I need to provide is where do I want to provision this database? As you can see here, it's a little small, but I can choose from Google, Amazon, or Microsoft. It's my choice. I can actually provision this database across multiple cloud providers. Remember, Cassandra is a distributed database. I can have nodes in my distributed cluster, some nodes in Amazon, some nodes in Google, and some nodes in Azure. Or I could have them all in Azure, but in different data centers. I'm going to choose Azure, Asia Pacific region, Australia East data center. And this is where I'm going to create my database. That's all you need to do to provision Cassandra. What is it doing in the background? I hope I just didn't cancel that. No, so it's currently pending. It'll take a minute or two to process that. What is that doing in the background? Excuse me, I just got lost with my... Okay, this is what's happening in the background. In the middle of the slide here, you can see 3 Kubernetes nodes. For those that aren't familiar with the logo for Kubernetes, it's the wheel, the ship's wheel, essentially. So right now, we're using Kubernetes to provision a Kubernetes cluster inside the data center at Azure. And on each Kubernetes node, we're going to install a Cassandra node. You can specify with Cassandra how many nodes are in a cluster. And you can also specify things like a replication factor, which determine for every piece of data that you write into the database, how many copies of that data should be created. As opposed to most databases, Cassandra, being a distributed database, is a peer-to-peer database. Every node, all three of them are active. Any write can happen on any node, and that node will replicate it to other nodes. And in the background, consistency is eventually achieved. There are quite a lot of controls that you have to allow for the trade-off between consistency being eventually achieved, speed, as in, do I want to wait for all of my replicated nodes to confirm that they've written the data before proceeding, or is it enough that just one confirms it and then I can proceed? What this gives is immense performance. I can be writing millions of requests in an hour, and each of those writes will be actioned in less than 10 milliseconds. So whether we're provisioning on Amazon, Azure, Google, or on-prem, we have our cluster provisioned. The other thing that's on top of that is a set of APIs. DataStax developed an open source project called Stargate. And Stargate is an API layer. Inside that API layer, you choose which API you want to work with. You can work with graph query language, you can work with REST, you can work with JSON document API, you can work with Google RPC, you can work with Cassandra query language, and on top of that, you can also work from whatever programming language you want with SDK drivers. And I'll show you a little bit about that. It just means, again, that for developers, you don't have to learn a new API, you don't have to learn a new programming language, you just keep working in whatever language you want, and Stargate takes care of everything else. I talked about distributed database. On the left-hand side, we have your traditional relational database management system, where even if you have a cluster, generally you have one leader, and all the other nodes are replicas, slaves. But every write has to happen on the leader. So the top left node, that can do reads and writes. The other nodes can only do reads. All writes have to happen on the leader. And if the leader fails, you're down. With a database, a distributed database like Cassandra, every node is active. It's peer-to-peer, and every node can handle a read or a write. So if any single node goes down, you're still up. And that's how we achieve such high availability. And it also means that we scale in a linear fashion. When I add more nodes, if I've got 3 nodes and I can handle 100,000 writes with 3 nodes, 100,000 writes per minute with 3 nodes, if I double the amount of nodes, I'll double the amount of writes I can handle. It scales in a linear fashion. Okay, I'm going to go back to the demo because that should be provisioned now. I quit out of it, so I have to go back to the old-fashioned way. Okay, so now I can see that my workshop database is now active. So what I want to show you here is if I enter the workshop database, now I'm in the dashboard for my workshop database, and I want to draw your attention to the tabs at the top. I've got my overview. I've also got a health tab, which for monitoring the database, how many reads, how many writes, what latency, what's the speed that the database is operating, all of that is provided for you. This is my favorite tab, the Connect tab. Why is it my favorite tab? Because I want to easily be able to connect to my database. I don't want to have to go to school to learn how to do it. So on the left-hand side, we have all the different APIs, all the different programming languages, all the different SDKs that you can use to connect to the database. And to work with one, I simply click on its title, such as GraphQL. We're going to work with GraphQL. And it gives me the instructions, but not just the instructions. It gives me all the relevant links as well. So this link here, launching my GraphQL playground, that link it might be a bit far for you to read where you're sitting. You're all sitting so far back. But Australia.east, that is a link to my cluster in the Azure data center. And it knows, it's given me the information I need. I don't have to figure it out. So if I click on that, straight away I go into an interface which I can use to interact with the database in GraphQL. If I want to work in GraphQL, I can do it here. So what I need, first of all, is I need an API key. For security reasons, I need a key that I can use to authenticate to the database. To get that key, I go back to my portal, organization settings, and I can create a token for any level of user that I want, because we need role-based access to the database. So in this case, I want to be the database administrator. So I'm going to go database administrator, generate token. And that has generated a new security token for me to access the database with administrator privileges. I'm going to download that. If I don't download it now, I can never download it again. I have to create a new one. And that's again for security reasons. So let's just open that up. And here is my security key. It's this one here, Astra CS. I'm just going to copy that. And we're going to go back to my GraphQL playground. And in the HTTP headers, I'm going to put my token, just paste that in. And now I get a response from the database straight away. So I've authenticated as a database administrator to the database. This is the URL I'm using here is the URL I use to manage schemas in the database, to create tables, to alter tables, that sort of thing. But I can also have a tab, and in this tab as well, I just need to make it smaller so I'm going to put the name of the database, Netflix. And again, we're going to put the key in. And now I can execute queries on the data, insert, select, etc. Okay, I mentioned that we have a little application. So we wrote the application in React. Don't worry about it too much. It's essentially JavaScript. React is a JavaScript library. And what we're doing here is, I'm just going to go down here to the response code. Excuse me, jumping around. And what we're doing here is we're fetching a URL. This is how we talk to the API, by just issuing a post, an HTTP post to the API. It's going to pass in a URL, and it's going to also pass in my Astra token. So I need to paste the URL to access the database and the token into the environment variables of the application. So I'm quickly going to do that. I'm just going to grab the URL from GraphQL, because we're using GraphQL, and then inside the environment, paste in the URL. I also need to grab my security token and paste that in as well, save that file, and now this code will now work. It has the URL, it has the security token. Here's the query that we're going to execute. This is a GraphQL query. For those that don't know GraphQL, the way to read this is select value from the reference list with the label genre. All right, let's execute some queries. So the first thing we want to do is create a table for that reference list. So I'm just going to copy, again, this query is in GraphQL, and I'm just going to paste it inside my GraphQL playground and press the play button. No, I don't want a dictionary. Say again? Thank you. I forgot I didn't copy it well. There we go. Better. Okay, that's done. It's always good to have people, smarter than me in the room. Now what we want to do is insert some genres into that table we just created. So this is just a list of genres for Netflix. Now we're going to go into and those are now inserted into the database. Now, this is not to show off database performance now. This is just loading some data so we can run the demo. The next thing I'm going to do is just run a query to check that all of those genres were created. Let's execute that. And I get back a list of all the genres. We've got action, anime, etc., etc. Or my personal favorite, somewhere down there, sci-fi. Next step, I need to create a table to hold all the movies. So that goes in our schema view, paste that in, execute that, and now we've created a table for genre. And lastly, to start with, I'm going to now execute the application. Okay? And to do that, I'm just going to use my terminal inside my IDE, my development environment, and execute it using Netlify. It's running on my laptop though, and that's going to open up a browser, and here it is. Now you'll notice that it does have all the genres. It pulled that out of the database, but there's no movies because I haven't loaded any movies into the database yet. So I just wanted to show you that it is actually interactive. Yeah. Now what I'll do is insert just a few movies. I think I've got 1, 2, 3, 4 movies here. So when I insert these, I should be able to execute my app again. And when I execute it this time, I should see 4 movies appear. As long as we don't have any technical difficulties. Okay, so Inception is one of the movies I loaded. Yeah, it's a good movie, right? Yeah, my personal favorite. So this interface is interactive. When I move the mouse to the bottom of the screen, it loads the next 4 or 5 genres. It's doing it using paging, which is really easy in GraphQL. So here we are, 1, 2, 3, 4 movies in my favorite genre, sci-fi, loaded into my Netflix clone. Now that's good, but are we really going to use GraphQL Playground to load data into the database? Not if we're dealing with even how many words were in your dictionary?
I had 120,000.
Right, so I don't think we're going to use that interface to insert 120,000 words. What we might do instead is go back to my portal and use the load data function where I can just take a CSV file. Oh dear, technical difficulties. It'll come back in a sec.
Yeah.
Yep. Thank you. Okay, so we have a data loader built into the portal, and you can load data this way. Of course, there are other ways that you can do it. So I just have a CSV file here with movies. I'm going to dump that in. Click Next. Here I get a preview of the file, so we can see lots of movies. It knows what table it's going in. I need to tell it, for those that aren't familiar with Cassandra, the partition key, it's like the primary key, but it's more than that. Let's leave it at that for now. And which table or which database and key space am I going to load it into? Netflix. And that's it. It's going to load that in the background. Now, it is a background job, so I'm going to get an email that will tell me when it's finished. It'll take a minute or so. While that's loading, I'd like to talk to you a little bit about how you can be a part of DataStax's products, how you can participate with us. There's a few things that we do. Number one, top right, go to our Astra website and sign up for your Astra database. The one I'm using is the free one. I don't have a special DataStax staff account. I'm just using the same one that any of you would get if you went and signed up. The free $25 a month, 20 million reads and writes a month. And you can just sign up, no obligation, no credit card required. We have many small businesses and developers who have been using it for a couple of years now, and they never pay us a cent, and we don't want their money. We just want them to be happy users, and maybe one day if they work for a larger enterprise who does have more money, they'll talk about DataStax to that enterprise. That's how it works. You know, we don't need everybody's hard-earned cash. The other thing we can do is on the website, on the DataStax website, you have ways that you can learn. You can get certified, and some of these administrator and developer certifications that we have online workshops all the time. This Netflix clone is available as an online workshop. We call them samples. From the developer portal, you can see all of these samples, and if you want a quick start, how do I get going? We have samples for all different types of languages and APIs and different technology that you can use as a sample to get you going. And we also have a online academy, the DataStax Academy, where you can learn about Cassandra, about NoSQL, and go as deep as you need to for your project. All right, let's see if my load has finished. I'm going to say no, just based on time in. But I'll check my email. Easier on the phone. I got an email saying the job has started. That's good. And I got one saying it's finished. All right. So now I can go back to my clone and I load it now. And as you can see, suddenly it's full of movies. So really the focus of what I showed you today, let's not start watching movies. What we looked at today is DataStax's serverless offering of Cassandra called AstraDB, and how easy it is for you to sign up, get an account that gives you quite a bit of usage, and how easy it is to create a database there, access that database from different APIs. Even setting up role-based access to that database was just a couple of clicks. The fact that you can provision that database in any cloud provider of your choice and in any of their areas or regions just makes it far more powerful. Any questions?
Round of applause for Hilton. Thank you. So yes, here we go.
Couple of questions, sort of related. What's the latency for the data capture, and does it first replicate on a given number of partitions and then trigger an event, or after?
Okay, it's quite a deep question. So change data capture, for those who are unfamiliar, I spoke about event streaming, where we pick up on writes to the databases, changes to the data, and we can process those and stream them out. That's change data capture. Yep. So the latency on that at the moment, it depends whether you're using DataStax Cassandra, Astra, or DataStax Enterprise, or whether you're using open source. In open source Cassandra, the latency is about 30 seconds, too long. We have it down to 1 second. And the reason that is because we've developed an agent that lives on each node, picks up those changes, writes those changes into one queue topic in Pulsar. Pulsar is the event streaming solution. There's one topic in Pulsar to capture all of those changes as they come in. But because you might have a replication factor of 3, 4, you're going to get 3 or 4 notifications of each change. So the topic that they get written into is then processed and deduplicated, and any Pulsar functions are executed to process that data. And then it's put into a outbound topic where it's consumed by the end user. So the optimizations that we've done there, I mean, we get it down to 1 second. That's a fantastic question. Yeah.
Matt?
Just a question on your 100% resiliency model.
Yep.
Right? I assume that's just within one region. Do you have a multi-region model?
It is a multi-region model. So the model is multi-region. Let me explain, okay? You can have a cluster that has nodes across multiple regions. But generally what we do is we say you have a local cluster in each region and remote clusters in other regions. Yeah. And it comes down to in your queries, you need to specify the level of consistency and that you want. So you can say, for example, I want to read or write data with local consistency or with global consistency. Essentially, the consistency is specified at each query, and you can say, I want a consistency of one node. Only one node needs to respond. I don't care if any other nodes agree with it or not. One node is fine. Or you can say all nodes. And if you've got 100 different nodes spread around the world, all of them have to agree on the data before you get a response. Or you can say local quorum, which is the majority of nodes in my local data center have to agree. What's the local data center? The local data center is the local cluster, is the cluster that responded to the query, okay, where the coordinator was. That's determined by the partition key. So in Cassandra, the partition key is not just your primary database key, it's also the key that determines where the data is stored. That's how we are able to say, for example, if your partition key is genre, you could say every genre is going to be stored on a different cluster. So when you execute the query and you provide the genre, it knows where to go to get the data, which cluster to go to. So it'll do a local quorum on that cluster. You could also have then an expanded consistency check, which is beyond local quorum, and you could say global quorum. Does that answer your question?
So ultimately, the data's everywhere, but depending on how consistent your query is.
Yes.
So you want the latest data or not, you specify that.
In your query. And you do that query by query.
One last question over here. Thanks, mate. And we'll repeat it once you say it. Yeah.
You mentioned 20 million read and writes. Let's say if I have 10 nodes, and if I write once, then it would be considered as a 10 writes or 1 write.
In other words, if you have a replication factor across multiple nodes, that's also good questions. Yeah, I'm impressed. How many books have you got?
Yeah, 20 million writes across 10 nodes. How many writes does that equal for Cassandra, right?
So because the free tier gives you 20 million reads and writes, but you have a cluster with replication across the nodes in the cluster, does the 20 million count as, if I've got a replication factor of 3, do I have to divide 20 million by 3? No, that wouldn't make sense. It's how many writes or read statements you make, not how many database operations on a disk there are. Does that answer your question? Yep.
Awesome. It just goes to show serverless developers obsess over staying under the free tier. It's got to be under, otherwise they won't pick the technology.
I've been working with open source since '95.
Yeah.
Back in the days before Google existed, and when really you had to learn by reading O'Reilly books, hard print, yeah, we all do that. That was part of the attraction of open source, wasn't it?
Yeah. It's cool. Well, round of applause to Hilton. Thank you so much.
Thank you.
So at the meetup, we sort of like have a mix of sort of, your talks, vendor talks, just to sort of keep it nice and fresh, just so that everyone, like sometimes it's nice to get like a vendor along to sort of come and show what they've, come out with, see what's possible in the serverless space, using a vendor such as DataStax. I wasn't super aware of all of that functionality prior to this talk, so I really appreciate it. So yeah, we're always open to feedback. Just let us know what you're interested in, because that's the whole point. The meetup exists for you guys or you folks. So yeah, that's really awesome. There's a bunch of DataStax shirts just here. They're size small, so definitely not for me, but maybe someone here. I wanted to just say another big thank you to Rokt for hosting us, because it's, these meetups don't happen for free. Rokt have been super generous with the food and the drinks, so thanks so much. They're obviously hiring, so really appreciate that. Stick around for half an hour. Let's have a bit of a chat before we close the doors at about 7:30, and see you next month. I think we're going to be at CMB. They're a AWS consultancy somewhere in the city. So we'll get some details to you at some point when I remember to. But thanks so much. Appreciate it.
Thanks,